Okay. Um, Hello everyone, my name is Ilya Karpov, and today I'm going to talk about the fuse between NLP and social network analysis. So the idea of the talk is to discuss where NLP can help social network analysis and vice versa, where social network analysis models drive natural language processing applications and how they can benefit from each other. Yeah. And yeah, generally, this talk was originally designed for the UUSN conference organized in Ljubljana at uh, okay, it was in September, so long ago, I barely remember. Okay, so and it will be some kind of collection of recipes that can help you in everyday life, and that would be really interesting to discuss if you have any other ideas on this fusion. So what we're going to talk about generally, so this is the classical slide from half of the courses that I teach and that other professors give. So these are classical natural language processing and understanding tasks. So generally, some people say that natural language understanding is something more complex than natural language processing, because to process something, you do not need to understand what's happening behind. So some people say that there is no real natural language understanding because we have a very, very, very complicated smart monkey that just gives us feedback that we want to get some reward, but that's not so important generally. So there are lots of tasks here, and the most classical are things like text classification, clustering, named entity recognition, question answering, summarization. So some more specific like semantic parsing when we're extracting some semantically connected trees and knowledge from texts. Yeah, of course, machine translation and things like information search. And generally, when we're talking about applied tasks, such as happen at the social sciences faculty, we're usually focused on these group of tasks. Yeah, so we don't need question answering tool, because usually we're the one who are asking question to people, not for receiving it from the model. Generally speaking, it sounds pretty fascinating to make some sociological report based on a question answering done by NLP model trained on some given data set. So which means that this model thinks like some guy, and if you're asking the question to the model that thinks like some guy, and so the model is trained on his text, then probably his answer will be the following. Yeah, so it's a pretty fascinating idea, but I'm pretty sure it's not the mainstream of the current research. And in real life tasks, we're usually focused on pretty simple things to extract who is mentioned in the text. What is he doing inside this text? Are there any other entities and how they are connected? And usually all these tasks are called. So the first one is named entity recognition, and the second one is relation extraction. Yeah. This is the level of the document. Yeah, if we're talking about the level of the entire text, so we're usually interested in things like classification, when we need to label some text with some label, or with text clustering, when we do not have some combination of preset labels. So we're just trying to understand what's inside our data set and do some kind of data exploration. So I guess topic modeling is also somewhere here. I just so make it some part of text clustering, because Well, generally, I consider text clustering a more broader way, and you can do topic modeling with text clustering. There are some clustering algorithms that are extremely close to the topic modeling. For example, the expectation minimization-based clustering. EM clustering is exactly the same thing that the topic modeling was based on, so it's not here. Yep. So generally, we're going to focus on these 4 tasks and just discuss what can we do inside them and how SNA can help. Yeah. And the first idea here, and maybe some kind of research approach that we found recently, is the question of data-driven analysis. I guess so. All listeners from the social faculty should quickly understand the general idea. Usually, to get some statistics about some practical research hypothesis, we ask a question, organize a poll, and ask people to answer this poll. Yeah, and usually we're always limited by resources for this poll. We don't have enough money to make it offline, and online polls are pretty biased because so not all people are online, so it's always a question. And in fact, so we also have another bias based on the behavior of the users, because for me, I'm pretty sure I have participated in maximum less than 10 polls in my entire life, just because I'm too lazy to participate in them. Yeah, I'm pretty sure that many people do the same thing, and the distribution of these lazy guys may be unequal among the classes of the people in the poll. Yeah. So another way of organizing this process is just to extract the data exactly from people themselves. Yeah, just taking the social network as the source of data. And here we have a few limitations. The first one is that it's already almost 2024 and not 2012 or 14. And people now are pretty considered that they're being watched. So online media platforms do not share information so easily as they have done it a decade ago. And people are not sharing this information to the online platforms so easily. Yeah, so many people are just removing their accounts from the social network. This is the first point. And the second one, the same problem as I have mentioned with the online polls. It's really very hard and I guess almost impossible to make some alignment between online data, doesn't matter if it is online poll or just data from the online users, and the offline one. Yeah. So if we ask the same question inside to these different subgroups, we can get pretty different results from the question, and no one knows what will be the difference. Yeah, but if we are okay with these limitations, then we can do lots of practical analysis using data from online sources. Yeah, and one nice example that we have just okay, so it's being accepted but not yet published, so I can say pre-published, yeah, is the case of the inflation analysis based on online social data. Yeah, the idea here is that if we have some data set of people that we can analyze, and so for this case, this is just a beautiful picture of the contacting networks and different publics connected with each other. So you can see that it's the typical core periphery network where so colors suit for different topics being discussed. Yeah, and some topics are pretty isolated. So most likely it depends just on the connectivity threshold. So if we'll increase the connectivity, everything will be connected. If we'll decrease the connectivity, we'll get more these kind of islands. Yeah, but generally we have lots of communities that are pretty isolated from the main part of the graph, and we have different topics that are pretty interconnected to each other and exist in different parts of the entire network. It's pretty fascinating to discuss. So this is the source of our user behavior data, yeah, and we need another part, the source of the ground truth information. And in our case, the ground truth was the inflation rate. So the hypothesis that we checked was to find if there is any correlation between texts that people write inside social networks and the exact inflation rate. I guess it would be pretty interesting to repeat this work just on the contemporary data, because we have pretty high inflation just reported by the Central Bank of Russia, and it would be really interesting to see the reaction. Yeah. So, and the thing that we have done here is just the combination of okay, so not social network analysis, but social network. Yeah, so this large network and some NLP tools. So here we said that okay, we have different ratio of texts about inflation in different periods. For instance, we suppose that there are some periods with low inflation, and we suppose that if our hypothesis is correct, then we'll have a lower ratio of text here. And here we see that inflation rises 1 or 2 or 5%, and we assume that we'll get larger amount of text discussing this process. Yeah, so we have texts that have date attribute, and we can try to just build the classifier on this label data. Of course, it has lots of noise inside. For instance, so people are talking about different things: sports, politics, life, and I don't know, New Year, and so on. Yeah, and there are lots of complex correlations here. For instance, right now the inflation is high, and everybody are discussing what they're going to buy for the Christmas weekends and where they're going to spend this time. Yeah, so we can say that maybe this is some correlated processes, but it would be a fake correlation. So you should be careful with this kind of stuff, but generally, yeah, you can build this kind of classifier, and surprisingly, even the simple one is really working. And fun thing that comes out of this research is that it's pretty obvious to find words like dollar, ruble, inflation, and expensive inside the data set. But the interesting fact is that if you're starting talking about statistics inside any text, this is usually a trigger for the high inflation. So if someone applies to statistics inside his argumentation, it means that inflation is rising. Yeah, and it's pretty hardly to find fact if you're just thinking about this problem and deciding which words to pick, for example. Yeah, so it's pretty interesting. And the cool thing here is that we're not using some hypothesis from the very beginning that these words describe inflation or that one, and we're not limited by some group of people. Yeah, in this case, we have taken the entire region and took all texts within this region and correlated it as described, and it gave pretty interesting results here. So the idea is that if you have some ground truth parameter, and if you have a social network, you can try to extract the information directly from the social network using NLP tools, and then use this network as a predictor. So one of the possible extensions of this story is to scale this approach for other regions, and frankly speaking, we're lack on hands. So if anyone wants to join, and just to repeat this case for other regions, in Russia we have 87 of them, if I'm right. So you're welcome. Yeah, the second receipt here is about the usage of complex NLP tools. So, and a nice joke here is that when you're writing a paper, you don't need a co-author from the computer science faculty anymore, just because you have ChatGPT instead of them. And it's pretty hype and actively using technology. So there are lots of guides how to use prompts for GPTs, how to make them better, how to validate the answers of the model. So one of them here is just the picture of one of the first courses that I have met. But so the interesting story about it is not that it's one of the first course. It's more important that Andrew Ng himself recorded this video, which surprised me pretty much, because so I always thought that he's kind of more tough guy that is participating in more complex activities. And yeah, there are even best prompts that you can buy and prompt bases that you can use to generate some images, to answer some questions, and so on and so on. So for instance, you can visit prompt base and find something interesting for you, because sometimes those prompts are pretty sophisticated, and so you can pick those recipes. Generally, so we already had discussion about prompting at one of our seminars at the very beginning of summer, and even compared several examples on text classification, text clustering, named entity relation extraction. So if you're interested in how to do this with the GPT model, you can just go to our channel and find this video and borrow several prompt recipes from there. Yeah, but so the simple example here is that you have some text and you ask the model to read the text and then to return, for instance, relation about entities inside it. So maybe you already know the entities, or you're just asking the model about any entities here. Yeah, and yeah. You can also ask the model to return it in a structured way, in such a way that it would be easier for you to parse and to analyze it. For instance, ask to return the entity relations in triplets. Yeah. Here is the result. So you have entity, the geographical, then the kind of connections between another entity. Okay, here's it's not pretty entity in the common sense, but it may be an entity if you're focused on different beers and so on, yeah, and so on. So Lucy and Pastuzo give names to, and leaves, jungles gives hat. So you have several relations here. And generally, pretty obviously, you can see all the problems that come from this approach. So sometimes entities are not real entities. Sometimes you miss something. Sometimes there are some fake constructions. And for instance, it would be pretty complicated how to parse these. Yeah, if it's okay when bear wishes honey, but what are we going to do to go to London? It's not an object, it's some kind of intent that should be parsed additionally. Yeah. And the general idea here is that you can ask prompts in 3-4 different ways. And finally, just take the intersection of all the attempts that you have. It's also a pretty good trick to ask questions in different languages. So you can translate the text and ask the same question, for instance, in Russian or in German, wherever you like. Yeah, and different language models return different results for the same text in different language. Yeah, which can bring you some more additional records to this list. Yeah, it's always a question how to merge them and how to do what to do with the outputs that occur at the first list and don't occur in the second one. But so you only just to think it on your own. Another pretty easy to do trick is just to take several models. For instance, you can take ChatGPT and GigaChat and compare the results. Maybe they'll be a little bit different. So the real problem here is that from one point of view, you can do everything yourself and you don't even need to learn NLP or Python to do this. Yeah, so everything can be done using simple chatbots and online services. The more complicated and trustfully answer is that you still need someone that knows how to train those models if you need to get really strong result. Yeah, and here is just the little proof for these thesis. So all top models on the classification, and here is just the leaderboard on paper on oh God, papers with code. And you can see that papers with code on sentiment classification data set. And you can see that all the models here that are at the top of the leaderboard are still based on the classical encoder models based on transformers and BERT and so on. And that means that you cannot just get a state-of-the-art result with prompting and with picking just good prompt answers. Yeah, so encoder models are still stronger, and there is a pretty simple explanation for this because from one point of view, the generative model learns a lot about the world and it is being trained on the entire world size data set and has seen all the text, but you cannot fine tune it on your concrete particular task. Yeah, but the guy that is training the classical encoder model he can just ask, I don't know, 10 or 500,000 questions to the generative model and then use them for pre-training of his classifier. Most likely this result will finally be stronger than just the generalized model that we're using. So it's pretty easy to beat one or two top models if you can combine them and train on the differences that you have between them. And one of these examples is shown here. So I really like this paper, and yeah, this is another reason why do you still need a guy from the computer science faculty to understand what's happening here. But generally the idea is pretty simple. So they were using it for artificially generated text detection, and it was the competition within the dialogue conference 2 years ago, and they took 5 models already trained for language understanding. It was Rupert, several models from Sber, Robertex Large, and so on. Yeah, and they have made it cross-validation, so split the data set on several sets, and for each set they have answered so they have used one part for testing and 4 parts for training, and they have repeated it for each part. So they have collected the data set, the entire data set used for testing. And then for this data set, they have trained an additional regression model that predicts which models is better for this exact text. Yeah, so it's the classical kind of ensemble training. Yeah, when you're training on the losses. So you have an example and you have some loss for each model, which gives you some opportunity to pick the best option. So they have trained additional log-rank classifier on these cross-validated chunks, and it gave them an opportunity to pick the best model for each text that they are training. And this was the state-of-the-art result at the conference, and as far as I know, it is still unbeaten because so it works pretty well. And the same idea can be done with the generative models. So you can ensemble them to some group and pick those results from GigaChat, those results from ChatGPT, and so on. And you can combine them in a proper way and train your own classifier that will work better than each separate model, even if it is highly generalized. Yeah, so usually to do these kind of tricks, you need some guy that at least knows about them. And so usually if you're hunting for the pretty sharp classifiers, you still need some guys that know how to train them. Yeah. But for hypothesis testing and for MVPs of your idea, you can just prompt GPT and see if the result is okay, and it would be pretty quick and pretty cheap because so you have a pretty large free limit for asking questions to the model, and it's not really hard to ask more if you really need it. Yeah, so for hypothesis checking, this can be a pretty strong idea and good baseline. Okay, so focusing on the topic of today's talk, how we can improve social network analysis tasks with NLP data. Yeah, and for this, I decided to focus on classical GraphML tasks. So usually when you're working with graphs, you are interested in either node classification, which is so the idea that there is some node in the graph, you need to label it, for example. So this guy is good and this guy is some fraud, fraud making entity, or for example, if this is chemistry or this is physics if you are looking at the citation graph and so on. Yeah. Another task is the graph classification, where we're focusing on the entire graph classification, but we have some kind of small graphs, like for example, chemistry formulas and the atomic connections. And in this case, looking at the entire graph, you can say if it is, for example, toxic or not. Yeah, this is also kind of typical task here. And of course, link prediction, where we're just predicting if two of these nodes will become connected at the next iteration of our problem. So here, the most obvious example is, of course, the node classification, and we check it. No, okay, I have a limited picture here. So for node classification task, the most well-known paper is based on graph attention network. So it's just the subset of the graph neural networks. so just the network with the attention model, that exactly uses on one step the network connectivity, so the information about how nodes are connected, and on the other task, the embedding of the abstract that the exact paper has. So they have tested it on 3 data sets. One of them is Cora. By the way, I guess this is the picture of Cora data set. 2 others are Archive and PubMed, if yeah, I guess to those of them. And the cool thing here is that using GNN models, you can classify your nodes even if you do not have the entire distribution of answers. So for instance, you know the labels only for 20% of the data set. So for example, if we'll look at this picture, you will know the labels only of the central part of this graph, this one, yeah? And you don't know the labels of all the other nodes. I mean 20%, not just because they're located here, but some randomly selected 20%, of course. Don't be confused. And God and GNN can encode text features just by design, because they accept embedding of the node, and you can parse some structural information or additional properties of the node, like gender, age, and so on, wherever you have about your data set. But if you're working with text, you can inject textual embedding just obtained from BERT or any other encoder model, or even just computed by back-of-words model. So any of them would be nice, and you can incorporate different sources, text, images, just even node features, wherever you like inside these node properties, and then use them inside GNN just by design. And this leads to pretty good results. So the interesting thing about the core dataset is that originally this dataset was created something like 30 years ago, and it was really hard to classify those papers just using only the textual information, for instance, abstracts, and yeah, so the words inside those abstracts, or only the network information, because if we're using only the network information, then it's always a problem how to classify interdisciplinary papers. Yeah, so they're on the border, and it's really hard to say where this border comes from. So if this node is blue or green or even purple or gray, yeah, just because it's located here, and it's hard. And if you're doing the same with only the abstract, it's even harder, because the guy can write a pretty strange abstract, but cite loads of papers from different areas, and finally this paper will be more kind of mathematical, but but its abstract is written in a very sociological way. Yeah, so abstracts are pretty confusing in this case too. But if you combine both of them, you gain an extremely high improvement, and so this is just something very, very popular inside modern graph neural network approaches. Yeah, so you just inject the textual embedding inside your graph neural network model and get increase in 10 or even 15% of your finite metric that you're focusing in. Vice versa. So can we improve NLP models with social network embeddings? And so the quick answer is, of course, yes. So typically, when we're talking about NLP as the NLP based on decoder, or sorry, based on encoder model, for instance, BERT and so on, yeah, just we're not going to make those cheap prompts. We're going to train something. Yeah, you have some layers of transformers architecture, and finally you either have the classification layer here that just picks the most probable class, or you can add additional regression layer and get the regression outputs useful for tasks where you don't have a finite number of classes. Yeah, and generally, so it's extremely easy to incorporate additional knowledge to almost all tasks that you can imagine. So for instance, you're doing sentiment detection. Either you have additional information about the object that is writing this sentiment review, so its author. Yeah, just because, okay, this author is a hater. Yeah, all his reviews are negative. He is located into the center of the haters cluster of the network. Yeah, so it would be pretty easy to incorporate this information just as additional vector somewhere here and say that, okay, so we have the output of the model itself and we have an additional vector of the author. We can either use it at each transformer layer, which will be more precise, or just simply concatenate it to the final output and make a pretty simple classifier. We don't want to change the architecture of the network or add some additional adapters here. So it's pretty cheap and pretty efficient. But okay, so in many cases, we don't have the information about the author just because, so it's not conducted or wherever it is. We have the information about the object, yeah? For instance, with the sentiment classification. So suppose we are talking about companies or totals, yeah? It's pretty fascinating to find out that the same text written for 1-star and 5-star hotel leads to totally different rating. Yeah, just because. So okay, there were some cockroaches in my room, but I paid $5 for the night, and okay, I got free breakfast. Yeah, so I'm okay with this. And if you meet the cockroach at the 5-star hotel, most likely, so the text will be the same, but the final review will be terribly different. Yeah, and depending on what is being analyzed, and you can easily build a network of what is being analyzed just by extracting those entities from text. So this is review about this hotel. This is some text about this company. You can build this network and see if objects within this network are interconnected with each other. Yeah, so given the additional network information, you can easily inject it inside the encoder model and benefit from the improvement of your final classifier. This is exactly example for companies in Russia, another research that we have done several months ago. So here is the list of Russian companies. I guess you can find Sber, City Mobile, Planit, and other companies here, and even Higher School of Economics. Yeah, and so if you just sorry for this again. If you just classify only the text, then your final accuracy will be 6% lower than if you use this additional network and inject the position of the company within this network inside the analysis. So once again, why do you need this network? Just because so you can lack on the number of reviews of some company, but you know its position in the network, and then you can suppose that, okay, so I have an embedding of this company that, so it's something like the Sberbank, yeah? So, and I'm injecting my like Sberbank embedding inside my NLP model and get better results, yeah? So that's why it works. So this is the thing how you can easily improve your NLP classifier things. And you can even go deeper and go not only with classification models, but with the generalized language model. Yeah, not only just on some purpose, but the entire language model that learns how the language is structured. And so how we're usually doing it, we have some function of either contrastive or masked language modeling, where we can optimize the distances between different tokens and different documents just by repeating the sequences again and again for the given model. And last year we have proposed the method that injects the social network embedding, just as we have discussed about the classification, inside the BERT itself, not BERT for the given classification task, but for BERT as the language model for without some supervised learning. Yeah, and we checked different strategies, starting from the first token injection and ending with pretty complicated layer that keeps users utilizes this information. Yeah, and found out that the last one with the set layer model is the best one. And so here are some details for this model, but the final result is pretty interesting. Yeah, so usually when you're working with unsupervised model training, you're checking if the model becomes more or less smarter on the masked language modeling, where you mask a word and ask the model to say which word is located here. Yeah, and for instance, if you mask the word embankment, then BERT original, without any training, says that the most probable word here is the autumn embankment. No, I guess just because it's romantic and many people are writing about beautiful autumn embankments. Yeah, but if you add the additional St. Petersburg group embedding just here at this middle layer, you can get Nevsky embedding, Nevsky embankment, which totally changes the output of the model and pretty obviously becomes more smart. It understands the author context here. And the same with, for example, the author. Yeah, like we read Alexander, I don't know whom, today. Yeah, and I was pretty surprised. I have no idea who is Alexander Korolev. As I understood, it's a kind of popular producer, but anyway, so by design, Rupert says that it's the most probable token here. And if we inject additional poetry group embedding, we get the block for this masked word here. So obviously for short texts where you lack on context and cannot guess if this text is about poetry or if this text is about some St. Petersburg or so on, or some geographical position, you can compensate this lack of context with the social network information, and most likely you will benefit from this injection. Yeah, so, but usually these things are important for some generalized language modeling tasks where you're just training the language model that can say something and can generate some tokens. Yeah, exactly for generative models set. And if you're solving the classification task, most likely this recipe about injecting additional subject or object information inside just the classification layer would be pretty useful. Yeah, so it's more useful for practical tasks. So I guess it's been already 45 minutes. And I'm done with the talk, and I can answer some questions or discuss some ideas.
Hi.
Alena?
Okay, good evening. Thank you for the really interesting information. I think it will be useful for me in my future research. And I have one short and simple question about the chart on slide number 9. Can you explain, please? I didn't really understand what is the unit on the axis x in period variable. Can you explain, please, are there days since the beginning of the year or something else? What's it? Yeah, in the x-axis period. I can't hear you.
Yeah, okay. Here is yeah, the days from the beginning of the year, but it really is not so important because generally, so you have some time trend here and the textual time trend somewhere else. And the question is, if your textual time trend goes before the actual inflation time trend exactly at the same period or after. Yeah, so obviously you are observing the central bank report with some lag. So they say that, okay, the inflation is now high, but it became high because some time span and they have watched the prices inside the markets. So most likely we suppose that the real inflation trend goes before the reported by central bank inflation trend. And we need to align this trend somehow. So we counted it from the 0 day 3 years ago. So we took data for 3 years, and the 1st of January of 2090 was the 0 day for us. And then we just moved forward as timeline goes. So I guess this is the most detailed answer that I can give now.
Okay, thank you. I understand.
Okay. So, any other questions? Dasha?
Yeah, I have a question. Thank you very much, Ilya, for this presentation. I think it's really nice. I mean, I always like when we structure some knowledge. So this is nice that you structure different approaches and look at them from like vice versa. How NLP helps SNA and how SNA helps NLP. I have a question.
I have an update of this analysis,
Report.
but but I'm kind of working on it right now because recently we have found several articles that try to train graph and text embeddings simultaneously, and it's pretty interesting. But because when you train something simultaneously, you train both and get better results rather than when you train separately. But there are two main problems there. The first one is that they do not get improvement or kind of statistically significant improvement from this simultaneous training. And the second question is that their code is not working. So I have spent something like 3 days trying to make it work, but so I'm still struggling. So that's why I decided not to include it to this recent talk, because I don't want to confuse you and say that there are more interesting things that are already working, because they are exactly not working. But they have Q1 paper. Who am I to criticize them, even if their code is not working?
Oh, wow, that's amazing. So I have a question considering, do these models that you use, that can be used, so probably you know some of the models, so you created some of them by yourselves. So do they take into account the creation of, no, not the creation, but the how the topics are emerging through time. So can you use some of these models among those that you mentioned to study some, for example, some discussion in some social media, and so you can see how the topic is developing, which subtopics we can see in this topic, and so on. So do you know something in this regard?
So usually there are two different tasks here, and the first one is topic detection, when you say that, okay, I define my topic as I don't know, news, yeah, and another topic as sport or wherever it is. So you need to label your data with topics somehow, and this is the first step. And then you can build some trend prediction just based on the classical models like ARIMA and so on, or you can use more sophisticated models that take into account how those topics interact with each other. Yeah, and I have seen a pretty interesting paper. In fact, not only seen, we have also kind of forked it for the different tasks, for different course prices. Yeah, because for example, some different cryptocurrencies are highly correlated with each other, and if one cryptocurrency goes down, you can predict that another one will also go down. And this correlation can be described with the graph that you built from observing the time period information, how these cryptocurrencies behaved at previous periods, yeah, and by additional external knowledge, yeah. So they have proposed the model that uses this graph model in the currency price prediction. And right now we're doing some similar thing, but not with currencies, but with companies, because many companies are pretty interconnected with each other. And so if one company feels bad, most likely its partner will also be not so strong and not so well. And we can predict some effects within the company network using the same model. Yeah, so this is what is happening kind of right now, and you can adopt these ideas for topics, because if you can build the correlation model for topics, you can use it to predict how the topic will emerge or become smaller at the time series period.
Okay, great. I'm actually not an expert, I mean, at all in this sphere. But recently I have reviewed the paper for Monitoring общественного мнения journal. And the authors used, so they proposed their own methodology to study this development of topics through time. And they use a kind of combination of, as I understood, also their topic to create topics. And then they also use NLP to, I don't know, to somehow describe what are these subtopics inside these topics. So I will just trace this the publication process of this paper, and when it is published, I will definitely share. So I think that probably for you it should be interesting to have a look at it. But these authors comes from sociological community, so probably you might not know them.
Then we'll okay. Yep. Thank you. Thank you.
Thank you. Dear colleagues, do you have any other comments or suggestions, questions?
Yeah,
Ivan,
if
please.
I may, yeah, thank you. Thank you, Ilya, for your talk. It's really interesting to find out these new techniques. I'm also trying to do some NLP-based and network-based, well, I can't call it science, but some pursuits, let's say. So I'm mostly constructing networks using the notion of semantic similarity, using the text-based neural network models. And as I can see, you're a specialist in these topics, so I have some questions. For example, what are the state-of-the-art models for this particular task? Let's say I'm building a network using the abstracts of scientific papers and titles and abstracts of scientific papers, and currently I'm have a data set of like 1 million of such papers. These are the papers of Russian scholars. So I'm trying to make a network using these. I use this very simple mini LM model, which is the most popular of all the models. So or perhaps on Hugging Face for this task. And also I know that this particular model is used by some startups that are trying to implement semantic similarity, semantic network construction, speaking of the network science. Are there any newer, better models and specific models trained on scientific literature? I've tried Spectre by Semantic Scholar. Did not notice any difference, but I'm not a specialist in this, but it's interesting. What advice could you possibly have here for me for this task? And also, are there any, perhaps someone else is doing something similar, and perhaps someone is trying to do this kind of network building using Russian language abstracts? Because now I'm just translating it using, if I have some Russian texts, I translate them using DeepL and then feed them into embeddings. Thanks.
So lots of questions here. Generally, I guess DeepL is one of the best translators working right now. So I'm also using it for things like preparing different parts of my reports, and it works pretty fine. So the question here is, if you need to parse lots of text and you do not want to fight with the system that will ban you for improper use, you can handle Google Translate, and it can handle much larger amount of text without stopping you. Yeah, so it's easier to send a lot of text inside Google Translate. So I'll give you some hints if you'll get some problems, but generally, if you need to translate a lot of text, Google Translate is easier. If you need kind of quality, I guess DeepL is the best way here, and both of them still work kind of better than GPT for me. So you can also use ChatGPT for translation, and it works pretty good, but it looks like the generalized translation model works better than just the model that can do everything. That's my subjective opinion. I have also translated text with GPT either, but so to me, DeepL works better. As for the first question that you have asked, so generally, I have already highlighted the idea with GAT, Graph Attention Network, here, and let's just GAT Peter. I guess this would be enough. Yeah, because as I remember, Peter has a pretty nice page here that describes the general idea. Yeah, so you can also find the paper. Here it is, yeah, Graph Attention Network. And I guess the text inside would be pretty similar with his page. Yeah, but generally, so this is just the papers connected by the citation network, and colors suit for different different topics within this structure. So if you need to classify papers, as I have understood you're doing exactly this kind of thing, you can easily do it with GOT. If you're looking for state-of-the-art models, then most likely you should look at so it's the variation of GOT, but with additional parameters. So where is ours? Okay, so I guess you can Google just GNN, yeah, and you'll find it. So, but here is their paper. It's based on GOT, but with lots of additional layers within, yeah, and it leads to some better results here. So you can. This is most likely the state of the art or almost state of the art. Evaluation of the original graph attention networks paper published in 2018. Yeah, and this has arrived, oh, okay, already almost 2 years ago. But so most likely the best models here are so RevGen and yeah. This is the answer for your first block of questions. The short story is just take default GOT because it can be easily found and it's implemented in lots of packages and use it. And then if you will need 5% more of quality or 3, then just try to implement this one. Yeah. Because
yeah,
most likely it would be much harder to make this paper work than this one, because this one has something like 100,000 citations, and this one has just 20 citations. So it's not so popular, and it's not included to the most packages. Yeah.
Thanks. That's interesting, but actually, my question is a bit. It is what you just told me is very important, but my question was a bit simpler. I'm trying to construct a network. Basically, I find the relationships between academic papers using semantic similarity of the texts, like let's say abstracts or titles of papers. So my question was, what's the state-of-the-art method to do this using 2 texts? Basically, we're constructing any network of small texts using the semantic similarity. It could be academic papers, it could be some persons on social networks or anything like that, some descriptions of some movies, anything. I'm using the very simple and I found out already very popular model called Mini-LM, which was trained using Reddit and also semantic scholar corpus. But I don't know if this model is the state of the art, or are there any better ways to construct this general type of networks using semantic similarity?
So as I know, Mini-LM is just one possible approach to extremely high distillation of the original BERT model by reducing most likely the number of attention heads, which is something that you can do after training is finished. So again, depending on your purpose. Obviously, as a distilled model, Mini-LM cannot be state-of-the-art, because when you distill something, you always lose quality. Yeah, obviously. Okay, most likely, BERT base or BERT large quality for the same task would be higher, just because BERT base or BERT large is larger. Most likely, models like Electra and Roberta trained on additional tasks would also be stronger than Mini-LM. And just because, again, they're larger and they're trained on larger amounts of tasks. And even kind of encoder models that are trained on very large number of tasks like T5 would also be still better. But the question here is better on what? So maybe for your task, Mini-LM is quite enough. And it's quick just because it's lightweight.
Yes.
So you're asking for SOTA. So the answer is try something like T5 or Electra. If you need to parse thousands of texts and do it quickly with limited resources, I guess Mini-LM is the right thing for you.
Yes,
you can also look for what they say about Albert or TinyBird, but most likely TinyBird will be worse than Mini-LM. Albert will be the same with Mini-LM. It depends on the task that you're doing and your subjective feeling with the result. So if you're okay with the result, then it is okay. So if you need a lightweighted model, look for Albert. Maybe it will help you.
Yeah, thank you.
Yeah, you're welcome. Okay, any other questions? Okay, 7 o'clock. I guess time to do something interesting, to write more papers. So thank you everyone for coming, and see you next seminar.
Thank you.
Yeah, Ilya, thank you very much.
Thank you.